Hello guys, in this video I am going to solve question number 53 from chapter 5, which is on maximum power transfer theorem. And this is from the book Engineering Circuit Analysis by Hayt, Kemmerly. So over here the question is that we need to select the value of RL. RL is over here, right? So we need to select this value of RL such that it is ensured to absorb maximum power from the circuit. Now, as I mentioned in my last two videos, that the maximum power will be transferred if the load resistance, if this resistance is equal to the internal resistance. And how we can determine the internal resistance? By calculating the Thevenin resistance or the Norton resistance. So for this particular circuit, somehow we need to determine the Thevenin resistance. So how we can determine the Thevenin resistance? To determine the Thevenin resistance, simply we need to first step is to remove this RL. So if I remove this RL, then the circuit, it will look like plus minus, this is 5 ohm, it is 8 ohm, this is plus minus V1, right? Now over here I remove this RL, so it is A B terminal, and then this is 10 ohm, and then the dependent current source, which is 0.2 V1, right? So this is our circuit after removing the RL. Now in this circuit, since we have the dependent source and we know that we cannot deactivate the dependent source, so since we cannot deactivate the dependent source, so we cannot calculate RTH just by deactivating all the voltage and the current sources, right? So over here what we can do, we need to first, we are going to determine what is open circuit voltage, means what is the voltage across AB terminal, and thereafter once I found VOC, thereafter what I am going to do, I am going to short circuit this. And then I will determine what is ISC, short circuit current. And once I determine both of this, then I will divide it, and this is going to be my RTH. RTH will be equals to VOC upon ISC, right? So let's see. Let's first determine the VOC, open circuit voltage. So to determine the open circuit voltage, first of all we will apply, let this loop current be I1. So this I1, because over here AB terminals, they are disconnected. So as such, this part of the circuit and this part of the circuit, they are not connected to each other directly. But with the help of this V1, because this dependent source, it is controlled by this V1. So with the help of this V1, they are connected, right? But to determine I1, directly I can apply the KVL. So this is going to be like, this is 4 volt. This is 4 volt. So directly I can determine I1 as 4 upon 5 plus 8, right? Or first let me write a KVL equation. So minus to plus, it is 4. Now this is plus to minus, plus I1, and this is like plus to minus, so plus 8 I1. So I1 is 4 upon 5 plus 8, it is equals to 4 upon 13 amperes. 4 upon 13 amperes. Now similarly, now we can find the V1. V1 is the value of V1. It is 8 into I1, right? So I1 is 4 by 13. So it is 32 by 13 ampere. So V1 is 32 by 13 ampere. And now coming to this part of the circuit, let the loop current is I2. Now since I2 is the current that is flowing through this branch, and which is equals to 0.2 V1, so simply our I2, it is equals to minus of 0.2 V1. Now V1 is this 32 by 13, so it means minus 0.2 into 0.2 upon 32 by 13. So solving this one, we will get, solving this one, we will get, just a minute, VOC. Yes. So it will be minus 6.4 upon 13 amperes. So I get I2 as this. Right. Now what I need to determine? I need to determine VOC. Right. And what is VOC? Like if I take this as V2, then our VOC, it will be V1 minus V2. Right. Now what is this V1? V1 we already obtained. It is 32 by 13. It is 32 by 13 minus V2. What will be V2? Now I2 current is this, minus 6.4 13. Now it is I2 current is flowing in this direction, right? But since plus is over here, so we need to take the current as this in opposite direction. So our V2 will be equal to minus I2 into 10. So I2 is this, so it will be minus 6.4 upon 13 into 12. So it is 64 into 10. Sorry, into 10. So 64 upon 13 ampere volt. So substituting this value over here, we get 64 by 13. So it is minus 32 upon 13 volt. So our VOC, it is equals to 32 by 13 volt. So this is VOC. Now similarly, we will try to determine ISC. So to determine the ISC, let me remove the irrelevant things from this to determine ISC. Now to determine the ISC, what we need to do? We need to short circuit this AB terminal. We are going to short circuit it, and we are then going to determine this ISC. Now since over here in the circuit, now we have three loops. One loop is this, let it be I1, second loop I2, third loop I3. So simply we can apply the mesh analysis, and now after assuming the loop current, let me write the KVL for the first loop. So first considering this minus 4, now this plus 2 minus, so plus 5I1, and then for this 8, it is 8I1 minus I2 equal to 0. Now for this second loop, it will be, for this second loop, it will be, for this 8, it will be 8I2 minus I1. Then coming to this 10, it is 10 I2 minus I3 equal to 0. And then coming to the third one, this third loop, it is like for this 10, it is 10, or since in this loop we have a current source, so our I3 value, it will be minus 0.2 V1. It is minus because the direction of I3 and this dependent current source, they are in opposite direction. Now V1, what will be V1? V1 is this, so V1 is this, so V1 will be equals to current over here, it is I1 minus I2, right? So V1 will be I1 minus I2 into 8, right? So over here we have this equations. Now if I solve these equations, then I will get I1 as 0.089, I2 as minus 0.356, I3 as minus 0.711, right? And now coming back to the circuit, what I need to determine? I need to determine this ISC, and this ISC, it is like over here the loop current, it is I2. So this ISC is equals to I2, right? So ISC, it is equals to I2, which is equals to minus 0.356 amperes, right? So ISC is 0.356 ampere. Let me put it over there. ISC 0.356 amperes. Now we know this formula. Substituting the value of this VOC and ISC over here, we get RTH is equals to 32 by 13 upon 0.356. So we will get, if you solve this, you will get 6.91 ohms. So this is our RTH. This is our RTH. And now over here we do not need to determine the Thevenin voltage or the Norton current, because the question is simply, it is asking that what should be the value of RL such that it is ensured to absorb the maximum power from the circuit. And we know that the value of RL, it should be equal to the internal resistance, which is our Thevenin resistance or Norton resistance. So over here we just need to determine the Thevenin resistance. So, and we found that the Thevenin resistance value, it is 6.91 ohms. So it means answer to this question is that RL value should be 6.91 ohm to ensure, to make it absorb the maximum power from the circuit, right? So this is all for this particular problem number 53. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.